Hello, we are from BEA Section 1/2. For this mini project, our topic is about internal forces and stresses for the subject BEEA2363 Statics and Mechanics. So this is our team members. This is myself, Noor Iskandar bin Mokhtar, Nawfazal Kamal bin Mustafa Kamal, Raja Suara Anak Lelaki Raja, and Muhammad Syed Amirul bin Samsul Kamal. In this project, we have three agenda, which is introduction, calculation, and analysis. So for the introduction, the internal forces, force not change the mechanical energy of an object. Example, gravity, electromagnetic, spring, etc. There is always gravitational forces. It does not mean it will change the mechanical energy of an object, as there is force acting on it. Meanwhile, the stress is defined as the intensity of the internal force. The total tensile force is P divided by the cross-sectional area A. So this topic is about this internal force and stresses on this chair. So this will be our model here. This will be our not an FPD, a simplified version of it. So these are all the data. So if, for example, if I sit on here, let's say 80 kilograms, there will be 850 newtons acting on the chair. So there will be forces that will put strain on this spot and on this spot. So the calculation will be presented by our next member, which is Fazal Kamal.
Assalamualaikum. So today I will explain how we get the maximum number force, shear force, and bending moment. Okay, so this is our picture of the chair. This chair is weight 85 kg, which means that the force is 850 Newton. So this is the measure, which is the 50 cm and 65 cm. So this is our FBD, and this is firstly we find the equation of equilibrium. So sigma fx is equal to 850 cos 45 minus bs equal to 0. We get it from this point, which is when fx we use a cos 45, and for the sine we use a sine 45 degree, and for the bx we get 446.52, and for sigma fy use the negative because it's a different because it's a different direction, so we use negative. So and we use sine because it's at the axis, y axis. So we got the by equal to 850 sine 45 degree equal to 723.27. So for the sigma, for the maximum bending moment, so we got the mb minus 850 sine 45 times 65, because the length is 65 minus 850 cos 45 degree times 50, because the length is 50 cm. So at last we got 69,338.6 Newton meter. So for internal force, we got it from the here. So for the normal force, we got the sigma fs equal to and normal force minus 446.2, because it's in equilibrium, so So that's means the force at the ref and right is equal to 0. So when this force is 446.52, so that's means in this direction also 446.52. So it's for normal force. And for the shear force from the y-axis, that means that in the y-axis F1 we got 723.27 minus the shear force BB at here, because the direction the positive direction and negative direction is equal to 0. So we got the shear force is negative 723.27 Newton. So lastly, for the maximum bending moment, so we got the bending moment that we got from this calculation. We put for the new maximum bending moment, so minus with the new bending moment minus with the 446.52 times 0, because it doesn't have a perpendicular length, so we times 0. And for the shear force we time with 32.5, because we have the length here which is 32.5 cm. So after we calculate, we got the maximum bending moment is 45,832.325 Newton. So that's all the calculation from this analysis. Okay, thank you.
Okay, Assalamualaikum. Ini semua channel ini. Macam pertama, today I want to talk about analysis about this new project. So for this project, you can see that the three supporting components that make up the frame create two rigid assembly that may be studied as a single unit in the exterior response of the complete structure. We also note that the frame is statically determined due to the placement of the external supports. Additionally, we disassemble the frame and create individual free body diagram for each component. To make it easier to trace the common force of interaction, the graphic is placed in a roughly relative base. We have demonstrate the calculation of the bending moment, normal shear response force, and visualization of the finding in the moment, shear, and the normal force diagram, and the various static systems of the chair in details. Okay, that's all for me. Thank you.